In this quick video, I'll show you how to stretch or compress a function using transformations. The transformation of a function includes the shifting, stretching, and reflecting of their graph. Examples of vertical and horizontal stretches and compressions are shown below. Let's jump right into question number 1. In question number 1, they ask us to use the function f of x as shown to sketch the curve f of x is equal to 4 times f at x over 2. Now the first thing that we'll analyze is this 4 at the front. And above, it tells us that if there is a value in front of f at x, you will stretch the graph vertically by a factor of c, which in our case is 4. And the best way to do this is to concentrate on the minimums and the maximums of the graph, of the curve. Now in our case, one maximum would be right there, and one minimum would be right there. This oscillates between 1 and -1. Recall that f at x is another way of saying y. You're going to be taking all of your y values and multiplying them by 4. So technically, your mins and your maximums will be multiplied by 4. In our case, it's 1. 1 times 4 is 4, and -1 times 4 is -4. So this point right here will be 2, 3, 4 up here. And this point right here will be -2, -3, -4 down here. So technically what's happening is the curve starts to look like this. Now the next thing that we'll focus on is this part. Now let's take a look above at what that says. They say that if you have an instance where your x is being divided by the factor c, you must stretch the graph of y is equal to f of x horizontally this time by a factor of c. So let's do that. Now we just focus on the x's. This x right here is 0. So if we multiply 0 times 2, it remains the way it is. This x right here appears to be at 1.5. You're going to multiply 1.5 by 2. So you end up with 3. So this point right here, which was formerly at 1.5, becomes 3. So it goes over here. Next, this point at around 3 and a little bit, and you multiply that by 2, so it goes over here. And the same thing goes with all the other points. This point right here will increase by a factor of 2, and you end up with a highly stretched wave. Now notice, half of this purple wave extends a single period of the original. So 2 periods would be right here, would be 1 period of this new function. Now, to combine both of what we just did right here, we're going to use this graph, 4 and -4. And we know that it has to end right there. So we have the following situation. So that answers question 1. Let's move on to question 2. This question asks, use the function f at x as shown to sketch the curve f at x is equal to half f at 2 times x. So let's start off with half. Now if you remember, half describes compressing a graph of y is equal to f at x vertically by a factor of c. So this time we are compressing as opposed to stretching. This means that all of these minimums and maximums will have to be divided by half. Over here, we have y is equal to 1. We're going to divide 1 by half, which becomes half. So we end up with something like this. And remember, you always want to concentrate on the minimums and the maximums. Don't want to concentrate on anything else. So this point and this point will represent the new graph. Next, we will focus on this part. Now let's go back and see what that means. 2x. This tells us to compress the graph horizontally by a factor of c. So this time, all of our x values will be compressed by 2. This x value right there is 0, so 0 divided by 2 is what it is, the same thing. This x value will be compressed by 2, so it will be shifted to half the distance of where it was. So if we were to zoom in here, the distance from here to here will be cut in half, where we end up with something like this. This goes down, back up, and there it is. Now to combine these two together, we're going to go down here, and we end up with the following. Notice that the period of one wave has now shrunk into the distance of that in the orange curve. So there you have it. Two examples on how to stretch or compress a function using transformations. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, you may visit our website at studyforce.com. We are an online service for students seeking free homework help. See you soon.